Hello everyone, welcome. This video launches a new series called Intro to Mathematical Proofs. Let's begin by building up some terminology, some basic kind of terminology to help us deal with some very basic mathematical proofs. So just to begin, let's define even and odd numbers. So a number is even if it can be written in the form 2k, where k is an integer. So this means an element of, and then this fancy z symbol means the integers. A number is odd if it can be written in the form 2k plus 1. So let's think about this. The number 4 is an even number, right? So in that case, k would be equal to 2. The number 5, or let's just change it, let's make it 7. In that case, 7 is odd, and k would be equal to 3. So that's a definition to get us started. And now let's just prove a very basic fact that comes as very obvious or intuitive, but maybe you've never thought about it before. So let's write down what that fact is. So, or let's just state it as a conjecture for now, and just kind of in the spirit of this series, we'll state things as conjectures and then prove them, unless it's a famous result. Conjecture: the sum of two even numbers is even. It's a very basic kind of fact. You could check it with some numbers. Say you take 2 plus 2, those are two even numbers. You add them together, you get 4. 4 is an even number, so e.g. 2 plus 2 is 4. But now we want to establish a firm footing that basically tells us that this is true for any two even numbers that you choose, and not just this particular choice of two even numbers. So to do that, we prove it. So let's just write proof. So we need to prove it for any two even numbers, which ultimately means we need to take two arbitrary even numbers. So here's what we'll say. We'll say, suppose m and n are even. Those are the two even numbers we're taking. Now, this means that m is equal to 2k, and I'm going to use a subscript to distinguish, 2k1, and n is equal to 2k2. So we have expressed m as an even number because that's what it is. This is just the definition of being even. And then we've also expressed n as an even number. Now what we're trying to prove is that the sum of two even numbers is even. So let's consider the sum of these two general looking even numbers in this form. In particular, consider m plus n, that's their two even numbers, and that gives us 2k1 plus 2k2. We're just directly substituting in m and n. And then this is nice because we notice that we can factor out a 2, which leaves us with k1 plus k2 on the inside here. Now let's think about what we were trying to show. We were trying to show that this result that we get at the end is an even number. Well, it checks out because we've got 2 times k1 plus k2, and any time you add together two integers, you get back another integer. So this is, you could say, if you want to be a little bit more formal, I don't think it's necessary, but you could say let k1 plus k2 equal k3, which is an integer. Basically just relying on the assumption that if you add together two integers, you get another integer back. So you could then say that this is, I'm being a little bit informal here, but then you could say then this is equal to 2 times k3. k3 is an integer. So we have proved that the sum of two even numbers is an even number. Now, I leave it as a challenge to you to take what you've learned from this video and prove, so we're exercise, prove that the sum of two odd numbers is also even. So that's my challenge to you. That's it for this video. If this video was not very interesting to you because you've already seen these types of proofs before and maybe you've learned more complicated proofs, stay tuned. We're going to start off at a very basic level, but the idea is to build up gradually, and as we develop more and more tools, more kind of mathematical tools for understanding deeper and more interesting results, we'll get to that. So anyway, that's the end of this video. I will see you all in a future video on mathematical proofs.